All right, so we are reviewing parametric equations. And one of the first things that somebody said is, what's different about it is you have two equations to make one graph. That's true. Somebody else tell me something that's different about these, especially when it comes to the graphing of them. What is different about parametrics than you've seen before? Place of destiny, row 5, person 1, right now that's you. What else can you tell me about parametrics? There's a t for time in it. And what's also special about that t when it comes to the graph? How about this? When you have t on your chart, you don't have t in your graph. Let me show you what I mean. Next, I have a different person. The type of chart for this is called something special, row 5, person 3. That's you, GJ. The TXY chart, very good. And as I'm filling out a TXY chart, and I start with T, well, what should I start with? Should I start with 0 in this case? Row 4, person, last person in the row. Why should I start with -2? It's the domain, and it says that it starts at -2, and it gets bigger. Now, that doesn't have a limit on the top. That means you could go forever, but you should start with -2. Next row, row 2, if you want to go get some food, and pass the either kind of food if you'd rather. We're celebrating Pi Day today, so there'll be a little bit of craziness with the video. All right. So if I stick in a -2, let's actually figure out that point. Everybody take -2. Stick it into these two equations and get these 2 points. I'll pause for a minute while you try that. All right, when you stuck -2 in here, you should have got -5 for the x. And then for the y, when you stuck in a -2, you should have got -4 minus 1 makes -5. So -2, -5, -5. All right, I'm going to pause for a second. Okay, so after I've graphed a few points, you'd notice that I'm not actually going to graph the -2. But when I put -5 as a dot right here, what should I put by it that I wouldn't normally have to do in a regular graph? T equals, in this case, -2. You put this on the graph, but it's not like the x-axis or the y-axis. It's a label of the point. That gives this point 3 pieces of information. It's got its x, it's got its y, and it's got its time. That's one of the things that's cool about a parametric is you get more info. All right. Then this slide was supposed to be about converting to function form. You learned this yesterday, but that doesn't mean you really learned this yesterday. I tried to teach it yesterday. Whether you were picking up what I was laying down is a different thing. So I'd like you to try this one. Try converting it. And who can tell me the first step? You do something with the equations. Can you tell it to me not in sign language? Because solve for t. Excellent. Solve for t on both of them. Go ahead and do that. Solve for t on both of them. I'm going to pause while I do that. Okay. Solving this one for t, you just add 3 to both sides. So t equals x plus 3. And solving this one for t looks a little more complicated because it's got 2 steps. Adding 1, adding 1. Y plus 1 equals 2t, dividing by 2, dividing by 2. There. I got 2 equations. T equals this, t equals that. Now what do I do? OS. Yep, set the 2 things equal to each other. This t is equal to this t, and so x plus 3 is equal to all that. So I'm going to write that out. X plus 3 equals y plus 1 over 2. Now, I'm going to finish this, and I know you'd be able to finish this, times everything by 2, because you clear the fractions. You learned that from the top 20 a long time ago. And then you get 2x plus 6 equals y plus 1, and then you subtract 1 from both sides. And you got y alone. Y is equal to 2x plus 5. But you're going to be all satisfied with yourself, like, hey, that wasn't that hard. And then you're hopefully going to remember one more thing, because this would not exactly replicate that parametric set. Why? It doesn't have t anymore, okay, but you can't just say, well, it's deficient, it doesn't have t anymore. You have to fix that by having a different thing in there. What do? You got to add something to this to make it the right final answer. All right, if you don't know, then that means you missed something big yesterday. Yes? Got to put the domain in there. Can I just write t has to be greater than -2? T greater than -2? That wouldn't make any sense. There's no t in the equation. But we have to use that whole t is greater than -2 idea. Do you remember what to do? You change it from a t domain to an x domain. And what was x when t was -2? I'm going to go back to my, oh, I erased it, poop. Help me recreate it. You probably have it somewhere, your txy chart. It was -2, -5, -5, is that what you said? Okay, so then, what was, if t was -2, what was x at that point? -5. And therefore, my domain down here has to be in terms of x, because there is no t. So x has to be greater than or equal to -5. Kids forget this all the time. And where do you get it from? The precious txy chart. Just like the xy chart was your best friend in graphing, the txy chart is what you really use a lot in parametrics. All right, where does it get complicated? Well, when these equations are more complicated, that's all. Otherwise, you got the whole idea. This is it. Okay, so let's look at when can it be more complicated? When there's a squared in it. Let's like 2t squared minus 1. Just for a second, let's take an aside. Let's say you just had t squared equals 10. A lot of people think the answer is square root of 10, but they're wrong. If you square both sides, oh, next row, this row right here. Oh, you already got it? This row right here. Come on over. In fact, the whole rest of you guys, go on over. If you would rather have non-pi items, they're up in front. Okay, square rooting both sides. I know there's a square root involved, but the answer is not t equals the square root of 10. It's not even about simplifying the square root of 10. Instead, it's about the absolute value of t. You've got to have the absolute value on there, otherwise you miss the boat. Okay, this is going to happen probably on your next test. Okay, you guys, move as people can't see the board. Go ahead. So now that I got the absolute value here, because that's what this is, I know some of you still think, can't I just put plus minus on it? No. Know why? Because that's not what it is. If you actually graph this, it will look like this. It'll look like a graph, which looks like this. It's an absolute value. That's why we need absolute value of t. And then that brings up a whole different branch of math. If you have absolute values, you have to write two equations for that, and that's the whole t is equal to the square root of 10, and t is equal to the negative of the square root of 10. And then you can solve those two equations. Okay. This happens to be already solved, which is awesome. There I've got my two answers. Do you get then that parametrics can get more complicated when you try to put them into each other? Because you have to solve for t, right? Well, all of a sudden I end up with three equations. Because one of my equations might have been this, and I solve it, and now I've got more of a mess. Moral of the story, know how to handle squareds. When there's a squared and you're solving, you need the absolute value. Okay, so let's do one like that. We'll keep the x equation simple. And let's say that the y equation is 4t squared minus 1. Would you please try to put those two together on, oh, what am I forgetting that every parametric has to have? A domain for what? T. And I'm going to say t is greater than 1. I'll say greater than or equal to, just to make your life a little easier. All right, I'm going to pause for a minute while you change that into a regular function, not a parametric anymore. And it's got that squared twist to it. I'm going to pause for a second. You solved this one for t, and you got t equals x over 3. Raise your hand if you had that one right. Sorry, that's funny. Look at t. Okay, good. Then, this one. Did you solve this one for t by adding 1, and you'd have y plus 1 equals t squared, or 4t squared, sorry. Then divide by 4. If you got the order wrong, I forgive you, but that's what you should have done. And then you should have square rooted it, which would cause this to be an absolute value. Okay, if I only have an absolute value of t, it gives me 2 answers. It gives me both the one I see, y plus 1 over 4, and one that's negative. So I'm going to write 2 answers. T equals square root of y plus 1 over 4, and t equals negative of the square root of y plus 1 over 4. Okay, shouldn't use y and a 4 in the same problem. These look too much alike. All right, anyway, moral of the story, if you now have to put this into these, you have to do it twice. You have to do one right there, put x over 3 here, and one over here, which is x over 3 goes there. And I got 2 separate equations to solve for y. What a pain in the butt, but yeah, this is honors pre-calc. It's not supposed to be super easy. The concept is easy. Grinding out the algebra is hard. Okay, so at this point, you could square both sides, and if you're trying to solve for y, and then you'd times by 4, and then you'd subtract 1. All right. Not going to finish that one because it would take too long. Moral of the story, these can be more complicated when it comes to their algebra. All right, I'm going to pause for a second while we go look at what the homework is for you. All right, there's one more concept I want to talk through, and that is a point here and a point here. And did you get that there is a line associated with that? And in the old days, I would have said, here's 2 points. I see that cell phone. Put it away, please. Thank you. Here's 2 points, and use this equation. Y minus y sub 1 equals m times x minus x sub 1. But you know what? We're not going to use this equation because that's the old kind of equation. You instead are going to use parametric equations, and so you need an x equation and a y equation. Look at that. They're all set up. How are you going to get something connecting these 2 points with a couple of x equations? Well, first of all, do you get there must be a t involved? Have you figured that out yet? That there's x and the solve has got a t in it, and then the y's got a t in it. All right. I want you to get this idea. We're going to start here, and we're going to end here. And you have to tell people that. Otherwise, because these are directional. They go from here to there. They can't just kind of go back and forth. It is a directional thing. If you're going to start here and end there, and I'm going to help you zero in, scribble out the 2, scribble out the negative 3. That'll help you just focus on the x's, which will help you focus on this equation. And I bet you can figure out what the equation would be that will get you from 4 to 8 using a t. All right, and then here's one last thing. Since you have a choice of anything, pick t equals 0 for your first point and t equals 1 for your second point. My t got funny there. 0 to 1 is a great way to go. It's so much cleaner than the other options. Okay? So what little equation? You need something here to make a little equation to make this work. How will you know it worked? Because it would reproduce the first point. It'll give you a 4. This is generalizing, kind of like your lab. You need to generalize with a t. And for the second point, when you stick in t equals 1, it'll give you 8. I want to pause for a second. Let me see if we can figure that out. All right, so you said you think it might be 4t, and then what? Plus 4. Now, if that's right, and there's something like that that will work for sure. If that's right, when you stick in t equals 0, you will get 4. Does it work for that? If I stick in t equals 0, do you get 4? Yeah, you do. That works. Okay. Does it work for the other one? Where you stick in t equals 1, does it give you 8? Yeah. Cool. All right. So here's what you could have said for this. You could have said, all right, this is like your starting value where time is 0. Does that make sense to you? You could, whatever this starts with right here, that can be right here. And then, how much did it grow by? That can be right there. Okay, 4t plus 4. I like it. I like it a lot. So then, can you now do the other one? 4t plus 4 worked for that one. Try to figure out the other one. It's kind of like that. This one is not growing, though. This one is shrinking. It's going to be slightly different. How many of you knew that I was going to start with plus 2 at the end there? Raise your hand if you had a plus 2 at the end. Okay, good. And this is how much it changes. Okay. And then, did it grow or shrink? It shrunk. It went down from 2 to negative 3. So how much did it go down? So did you say minus 5t? Raise your hand if you did. Awesome. Now, how could I know I was right? Because if I stick in t equals 0, it will give me 2, which it does. And if I stick in negative 3, sorry, if I stick in t equals, I lost my t equals 1 here. If I stick in t equals 1, it should give me negative 3. And it does, so I know it worked. Yay, you figured out the main other thing I needed to teach you today, which is how to get a directed line segment. This is a line segment, and it had a direction. Remember the start and the end? Because this equation would have been different if it went backwards. The numbers that we here, these two numbers, which came from here and here, they would have been reversed with these two numbers. Okay, so I'm going to get to the homework again here. Okay, so we're on day 2, and you'll find that these are very similar to the other ones, except we have squared coming up a little more often. Okay, so I'm going to have you do that one, and this one, and here's one of those directed line segments. Let's do 2 of those. We're going to do this one. That's just like what we just did, and this one. So 4 homework problems for tonight, and that's all I got for you for today.